Okay. Awesome, Venkat. Thank you for reminding this. This is great. Welcome again, everyone. For recording sake, this is another session. We are going to wrap the batch processing, where you learn how to read, how to write, how to do the transformations, something like this. Basically, you'll be able to read and you'll be transforming. You'll be writing. Very simple, guys. You extract, transform, and load. If you can do this, a lot of work is done. That is the beauty. You see? Now you're getting it. You're getting it. Then when you need to know more details about when you store. Reading is simple. Hey, you have at some place, data will be there. Just read it. You got it. But you transform it, that's where you need to do the work. Pyspark. When you store it, you store as a table. It sounds simple, but you need to know more, because there is a metadata involved. There is a table definitions involved. Is it a managed tables or is it an external table? Where is the location of the table? What are the keys of the tables? That does the table. Can you override this table? Can we append to this table? Can we merge? If we get a same data in the sense same keys, can you merge? Can you match? But how the storage is, first of all, where this data resides. Okay. Where this data resides. So suppose I don't use Databricks. My company doesn't use Databricks after some time. What happens to the storage? What happens to the data? So how the compute and storage is separated. These concepts you need to know. This is new. Because if you use Oracle, compute and storage is together. You need to take the data out of Oracle by yourself. Otherwise, if you delete Oracle, all your data also goes. But here it is not. This architecture is new. For new people like Manasa and Shanmuka, since everything is new, you don't know the difference. So that's where experienced people also, Subbu, Sairam, need to change your thinking a little bit about these technologies. These are different.
First unlearn and then learn.
Correct. Unlearn. Oh, Harun is coming up with good leadership as per unlearn. Sairam. Before we learning, we need to unlearn world things. That's what Harun giving Gyan. I like it. Awesome. Unlearn. So then the new things will be able to. So that is where tomorrow he'll be touching. So next week, we might have a little bit of this, but we'll be doing this streaming. Streaming means real time. I'll not talk much about that. So this week and next week, we'll be doing that way. We'll be very good in this green area. Then we'll go to the internal, etc. But let's go here. What we're going to talk. So you might have seen, you already have, remove this. You already have a compute. This is the compute. When you run your notebooks, Sairam, you're reading, transforming, and writing. When you write it, you'll be you're writing to tables, or even you can write to disk also. You'll get to know soon. But mainly the different catalog like this. Let them come. So, okay, now it's gone. By default, you will have a default database. Shanmuka, what is this? This database will contain tables, correct?
Yes. Yeah.
So see here, the very fact you are able to see the database this is a metadata. This is called metadata. The real data is that displays the customer data, product data, etc. Let me pull my notebook. Okay, second notebook showing you. See, this notebook is detached. It should be attached to a compute. Otherwise, you can't run it. We know this. You're reading some data. Let it run. Just when I is reading it, the data is there in this is the storage. The storage, this is a database storage. The storage can be S3 storage, Sairam. S3 means in AWS, it is called S3 storage. If it is in Azure cloud, it's called ADLS. ADLS means, let me.
Azure Data Lake.
Azure Data Lake, ADLS. ADLS is Azure Data Lake Storage. S3. What is that? Simple storage. What is that? Simple storage. There is one more S.
Service.
Okay. Who is that? Ravi. You need to tell me. Simple storage. That's it. There is one more S. S3. This is S2 only. Simple storage solution or something. You go and see. Huh?
Service.
Surveys. Okay. Awesome. That's it. S3 means simple storage service. Yes. Like RRR, right? R3. That is S3. Sairam, you like this? You like this, Sairam? Awesome.
Yeah.
Awesome. So you have this one. So this is a storage. If it is a S3 storage, you'll be using something like that. Nothing like S3, something like this. S3, something like that. ADLS, you may have ADLS, something like this. Or some other. Just Hadoop storage, HDFS, like this. That columns will be there. That is the notation. If it is a database storage, you can have something like DBFS. Or by default, you can leave it like this. That is a storage. That's where the data is. This is the compute. So that is what the meaning of people say compute and storage are separated. Okay, this is the people data frame. I can display this. This is the data. Which is the data? The data is what you see is the data. Right? This is the data. But this data frame, Sairam, when I run this program, you are able to see this data frame. But when I close this cluster or when I leave my system, when this notebook is detached, the session is lost. The session is lost. Then what is people DF? If I look here, what is that? Detach. We can detach this. Yeah. If I just detach, no, it's detached. What do you say? See here. It says nothing is coming.
No compute.
No compute. Name DP is not defined, it says. Even when I attach also, reattach also, the session is lost. Correct? Sairam? Shanmuka? So I need to rerun it. It means that is a temporary memory. It is not stored anywhere. It is not stored anywhere. Now if I run it, I have. Okay. That's why we store this. We store this. How we store this? That is where we need some database. We need to store that table. That's where, since if I already have a database, I don't want to use default. Usually in regular systems, if you create database, you won't lose it. This is a, what you call this, a community edition. They remove some data. That's why even you might have created this database before, but you don't see it. Now, Shanmuka, you know this, right? Catalog, this is the Explorer is a schema.
Yes, sir.
So now you are going simply, you're taking the data frame and writing, write mode. I'm using overwrite because they are keeping that in the storage. So I'm writing it as the Explorer people data. So this is where I'm storing it, because now I don't lose it. Of course, we are losing it since it is a community edition. That too, if you shut down your cluster, you come back. But in production or in real work, in real software, you will not lose it. So that's where the tables will be created in the Explorer. Because it's still running. Is it big? People is a small. Sometimes it may be slow because of resources, but generally it will be faster. No? So what happens is you will see the tables here. This is the database. This is the table. Table will be coming. So question to Shanmuga, right? What you see here is Explorer's data? No, Explorer is metadata.
Yeah,
Is
it's
the table
basically
name. Table name is metadata, correct? Metadata. Then the table will have properties. It means this table has what fields. This table has what keys. Or this
key.
table's location is, where is that location, etc. It is a metadata. It is a metadata. So your storage, even though we are saying the storage will be there. The storage. This is the, see here, this is the metadata. This is the metadata. Now it opens up. Look here. Explore.people data. See here. This is sample data, though it says this is the schema. But what you see here, this is the data. The metadata is data about this data. What it says, what it's saying is, hey, this data exists on a sample data, which contains, of course, ID here, you know this, but more information is here. This ID is a integer, etc. And even though it says here string and integer. So in earlier these things are not there. This is recent improvements. Gender is a string, birth date is a timestamp, but all this information is here. You see here? This is called metadata. Metadata. Even you will have a history. History. What is this history? So when it is created, when it is overwritten, all these informations will be there. This is what you see this Sairam. This is a metadata. This is a metadata. So your storage, your cloud storage or whatever whatever you are storing it, what format it is storing, what format it is storing. Now that information you can get even in by saying it in a describing it. Did you remember this, Saira? Describe that table. It means you're metadata. You're listing the metadata. It has these columns. This is a simple description, but describe, extend it. I want to know more details about it. More details. Look here. It not only gives the columns like this, it gives you more detailed table information. Which catalog it is, which database it is, right? Which table it is. So it is a catalog of database, catalog of tables. That's what we call as a catalog. So a created time, last access time, but most important thing, location. Where is this location? Location of the data. Shanmuga, are you seeing this? Important. Type, managed or external. There is a two types, managed or external. Those things Harun will be helping us. And provide a delta. Generally, by default it is delta. In industry, there are some general Parquet tables also. You might see the two tables, Parquet tables or delta tables. There is some other concept called iceberg tables. So there are different formats in the industry, but now the formats are coming closer. The delta formats is created by Databricks. Iceberg format is created by Apache Iceberg, a Netflix team. But recently, Databricks purchased Iceberg team. But Iceberg is used in Snowflake. So these two are coming very close. Going forward, now there may be Delta, Iceberg, they will be coming close. So all these details you'll be learning soon as we discuss this, the storage, metadata. Most of it you'll learn in next 2 days, but another 20% you'll be learning before you complete the class. But did you get this, Sairam, Ravi? Did you get some idea what exactly this metadata is, how important it is, at least a sense of it? Shanmuga? Ravi?
Yes, Trini. Yeah.
Super. So you need to have very clarity. Oh, data, this is metadata. You should really talk these words very, very comfortably, especially this managed external. Location. Yeah, yep. This is the default location. Managed means managed by Databricks. You may have external tables. The catalog. Soon we'll be even introducing a concept called Unity catalog, more secure catalog. These tables access, role-based access, right? Who can read, who can write, all those things can be controlled by Unity catalog. Very good. Now, another 5 minutes. Look here. So that is what the Delta Lake storage, that module Arun is going to touch. Okay. There is another concept already Harun has introduced to you. A raw layer, refined layer, gold layer, a bronze layer, silver layer, gold layer. This is a logical understanding of the data. Just like your house means a living room, bedroom, kitchen. Sairam, what happens? You know a lot about now real estate also. So Sairam, if I say house, hey, why I can put my kitchen in the bedroom. I have a bedroom, but I took a stove into the bedroom and cook biryani. What is the problem, Sairam?
It won't happen at all.
If it won't happen, if you think it can happen. No, you take a small stove and go and cook.
Here in US, you'll get alarm.
Huh? He says you'll get beatings from your wife, he says, Okay, Ravi, he's not married, but still already he knows the future,
No, Srini, I have almost 3 to 4 sisters, so I know everything.
Okay. Awesome, Ravi. I totally agree. So it's a common sense. All this bedroom, this is a logical structure, so that there is a structure to the house. That is the whole idea. Like that here, to manage this data is complex. See, one table is okay. If you have 1,000 tables, 2,000 tables, 10,000 tables, then some data is needed for reporting, aggregations. Some data is needed for machine learning and downstream systems. Or some data is just raw data. So this is the common accepted logical division of data in the industry. What does it mean? Hey, bring all the data and don't change the data. Bring it into the tables. Don't change any columns, etc. If someone asks, hey, how this data came? Oh, okay. This is how the data is when it came. Okay. So store immutable. Don't change it. Don't change it. First is store it. Oh, this is how the data is. You don't have to go to CRM systems. You don't have to go to the CRM systems, HCM systems, financial systems. If there is any issue with the data. Oh, how come this data came? Oh, go to PeopleSoft and see. No, you just see here. Hey, this is how the data came, first of all. Okay. Then you are doing transformations, right? Now you know, Shanmuka, you know Pyspark, you are very excited, you are playing with data. Harun, Shanmuka is saying, you feel like playing with data, So that's a great compliment for your training, He's very excited about playing with Pyspark.
Yeah,
Okay, you start playing it, and you store. If you store here, people get confused, So logical division. Hey, I played with data, I transformed. I'm storing it here, into a silver layer. Then all these layers can be divided in the form of schema. See here, in the same way, if I create I can probably Harun might have shown already. I don't want to take a lot of time, You can explore raw. Then another database, or instead of, let me say, sales raw, sales refine. A sales aggregation. Some people may use the word, okay, we can create this, right? We can create this. Or some people may use a sales branch, silver, gold. They may separate it like this. So like a folders in your laptop. So structure it. They structure it like this. Then okay, all the raw tables as is, put it here in the table format. Put all the tables here. Refine them. You are overwriting it, or appending it, or you are merging it, adding columns. All this, put it here.
Then a quick question.
Yeah, Saira.
Can we change the data type of the table about one of the columns before loading into table?
Of course.
Let's say if I read it as a text field or a string field, if I want to, but while loading, can we do it as a number?
Yeah, you can do typecasting. Arun?
I think dot cast.
Yeah, you can do, you can change it. That's where Pyspark comes into the picture. That is a part of transformation. Sarah.
Is a typecast?
Yeah, typecasting. There is a
So
cast
it changes
command.
the data type?
Yeah, string type to, right? Good question. You can do, it's very powerful. You can do actually even a lot more. You can even change the data using UDFs. You'll be learning. First, you got a good phone.
Data massaging, Harun told a little bit last week, but data types changing. Okay, so
It will come. This is endless, right? There is transformation is endless.
okay.
You'll get it.
Okay.
Or we'll share you some documentation, some sample scripts.
Okay. Thank you.
Almost anything you can do. Trust me. These are so mature technologies. Then the aggregations, you'll be loading it here. Then they'll be used for this. So if you go to a company, they may not, some people, most of the people knows this terminology, but some people may not know you go to a company. So that's where you work with Databricks teams, you work with your customer and make them understand what this. This is not a complex concept, simple organizing of the layers in a different way. Some people may say we need another layer also, platinum, more refined. Some people may say we may mix these two. It depends. So don't worry about it. It's a broad way of saying. So that is where you will be focusing on this particular storage. This is also part of the storage. That's why the module 4, Delta Lake Storage, the general storage of tables, Sairam Shanmugam, you can overwrite the data, you can append the data. But updating the data on the cloud storage was challenging historically. That's where these new technologies came, called Delta, the word Delta and Delta storage, iceberg storage. They support updating. It means merge update statements. Update statements are important for ACID transactions. ACID transaction, atomicity, few words are there. You see, just Google, sometimes even I forget. ACID properties of tables. See, like this. What is a transaction? What is ACID means atomicity, what is consistency, isolation, durability. This is general database concepts. So we will be discussing in the class. So it has a metadata, as I said, it's a scalable metadata. Then it has time travel. It means you can go back even few days, 1 week, 2 weeks, 1 month, old data. Sairam, if you screw up your transformations, you typecasted to string to something, but they gave requirement, you coded as per the requirement, but somebody came and said, oh no, that requirement is wrong. Saram did a good job. There's nothing wrong. I think we are going to change. Oh, okay. Then let me roll back my data to 1 week back. Then we'll rerun the updates. So the time travel. There is a lot of support for these. All these are open source, Delta and Iceberg also. Delta is created by Databricks. Iceberg is created by a company called Tabular. But now,
when you say time travel, you meant we need to go back to the stage of
correct.
Reading from the data frames?
No. That is complete. You are doing it. That's expensive, right? Time travel means, suppose you have table, Sairam, right? Today you loaded this data. Tomorrow you updated some 1,000 rows.
Okay.
In 2 days you updated another 1,000 rows. After the whole week you are updating lot of things. So every time you do one transaction, so the table has a newer version, right? It means it became a new data, correct? Because
so we go back to point in time.
exactly.
You can call it as versioning.
Table versioning, point in time.
Yeah.
Sairam, that is correct. Point in time. Go to that versioning. So you retain all that data. Then the delta, whatever you done this 1 week updates, you will redo, Sairam, right? Instead of again reading from beginning, you overwriting all these things, which is expensive for and the data is big, correct? Right.
Yeah, I got it.
Awesome. It's an open source and it supports both unified batch and streaming. So you see, it supports batch processing and streaming. We're going to do next week. It supports both. See, now you see the picture. These two will be supported in the storage. Beautiful. Beautiful. That's why these words are important. Unified batch and stream. Next, the schema evolution. The schema. Schema. This is a schema. This has a schema. This has a schema. Sample schema. Schema. It means this is the columns. This is the types. But suppose you want to change this. Add another column for the new data. New data. So it can have schema can evolve. It enforces the schema. It can evolve. Last 3 months, it has 10 columns. Now onwards, it will have 2 additional columns. No worries. You don't have to even alter the table. It will, your ETL can make it evolve. It's a different way of columnar storage. Then audit history. Who updated it? Who filled it? All these audit histories you can capture. It supports DML operations. Update, merge, all those things. It's as if OLTP, but it is not OLTP. It's a OLAP, online analytical processing, but it is very powerful. It is robust. All the ability of oracles have come here, even though we don't use it like a OLTP. Because Oracle, MongoDB, all those things, NoSQL databases, all there, But this is the cloud storage. You're using distributed computing. And that storage is very strong. Your data is quality. You can maintain the data quality. Otherwise, you don't know what you're writing. You don't know what is you're updating. You don't know something messed up. You want to go back. It is crazy. Data is scary, right, Sairam? Be honest, when you're running payroll, if the data is not consistent, it's crazy, isn't it? It's crazy and scary. Especially in the Ben admin, we worked in PeopleSoft, Ben admin, something goes wrong, we don't know, we'll have to redo, right, Saira? You remember our experiences?
Yes.
Super awesome. So Sairam has a lot of experience dealing with data. Murali, you also worked in CRM systems, right, Murali?
Yes, Srini, yeah.
Yeah, how much data you handled?
Yeah, huge data, especially if you're in the retail, huge data, it comes. Millions of records comes on the daily basis.
Subbu, you also, right? You handled a lot of data?
Yes, really.
Yes, guys. If you don't have control on the data, it is scary. Suddenly, I was working in electronic arts. All our jobs are running good. UAT passed. They said everything is good. We went to production. They started seeing, oh, this data wrong. This is benefits of something. Harun is working so hard, but he has 3 kids, but it is only showing 1 kid. What happened to other 2 kids? It is literally scary. Oh, then what should I do? You guys approved. Then there is a bug in the code. Oh, Srini, no. How come you can make current kids missing? you know. No. See, the problem, we'll fix this, we'll reload it. Even though it is their responsibility, still it will come to us, guys. Right. So that's where at least we know where is the issue, etc. So that's about this. So this module is very important. So Arun will wrap up a Pyspark batch, any additional transformation related code, etc. He will provide us reference links. Then he will touch the fourth module. That way we'll consolidate these 4 modules this week and next week. Then on Sunday we'll be starting on the streaming. So that way, again, I want to show you, you should be very, very comfortable to talk about these 4. This is like a foundation. You're building a house, it has a foundation. Then we can build the, what do you call it? The slabs, pillars, slabs. This is foundation and pillars. This is all the slabs and the walls. Then we can do all the interior, all those things. Awesome, guys. Harun, you want to add anything before you take over?
No, Ashwini, I think, yeah, we are good. We are doing the strong foundation of all the basics, which is very important. Whether it is Databricks or not Databricks, these are mostly the industry practices that we are doing with the data engineering.
So this is what companies do. You guys need to focus, refocus. Manasa, Shanmuga, Vedavas, how you become expert? It's very simple, guys. Just focus on 2 months. Then the 3rd month onwards, it's a game. Just attending interviews, writing certification, understanding the use cases, etc. Just 2 months. Put effort every week. Class. A lot of people study 1 year, 2 years MS, 1 year this one, 1 year Java, that thing, this thing. Time will go fly like anything, guys. If you're just starting, you'll have a lot of hope, but a lot of people lose a lot of time. So focus 2 months strongly. The class, understand the concept. Repeat in the week. Reproduce whatever Harun has shared, whatever I discussed in the recording. We are bringing cream from the industry. Then you'll get strong confidence. Then it's all, game updating. Awesome. Without wasting time, we spend a lot of time, but I think Harun is a good discussion. Let's prepare their mind for this week, for next week.
Yep.
Right?
Definitely.
Awesome. Any questions? Harun, you can take over. Any questions, guys? 1 minute.
Yeah, this community edition, is it like a forever thing, or is there a time limit for this community edition?
It's forever thing. It supports 80% of your classwork, but 20% get ready to install the some paid version. So paid version. Keep some $15-20 ready to pay for.
Paid version means to have that either S3 or Azure?
ADLS and some workflows, some additional features that are not supported in this. Sarah, is that okay?
Yeah, that's good.
It's a matter of $10-15.
Yeah, that's good.
Murali, feel good? So Subbu, Ranjit,
Yes,
Vedavyas,
Srini.
how are you doing today? Vedavyas from Tampa, you're on mute. Okay, it doesn't want to unmute.
I'm good. I'm
Good.
good, sir.
You started liking this. You want to commit for this course for
Yes,
travel
yes,
with
sir.
us?
Yes, sir.
Okay. If you have more interesting things, let me know. Even I will leave this and come and join that. But this is absolutely, guys, next 10 years, you can count on this. Awesome, Harun.
Okay.
Take it forward, everyone. So I'm counting all of you for the next 2 months. Okay. Awesome.
Yeah, thank you, Srini. Just give me 1 second. Let me share my screen. Okay. All right. Welcome, team. So we'll get started with where we have paused last week. Can anybody recap what we have done last week? Murali?
Yeah. Last week we did some kind of transformations, select columns in the data frames and rename and count group by. So yeah, these are things, and you gave an assignment also, right? Find the average as well for the particular the movie and from the ratings.
Mm-hmm. Okay, so have you guys practiced transformations?
Yes, sir, and yeah, I did.
Okay, that's good. That's good. So what about the exercise? Has anybody done that? What we have we're talking about here? Average rating for each movie.
Yeah, I did that one, but the second one, I don't have any data or whatever. To
That's
get
okay.
it
I was just giving you the business context
Yeah.
of what you
So
will
the
do.
only thing is, Arun, so the first one I did it, that one. The second one, actually, I tried to kind of mimic the same scenario for the movies and ratings. I tried to get it that average movie rating, but I got it from the sequel. But the Pyspark, I'm not getting. So I'll ping that one, the sequel, what I did. And yeah, you can tell me, Arun, so if it is possible.
Yeah, sure. We can check that.
Yeah, let me put it.
Right. Okay. Till this part. We have done the joins, and then we have done filter, and then done the transformed data here. We created silver table. And we did count of each, release year, what we were doing here. What is the count aggregate, right? Movies count data frame, year and count. So till this part we have done. So we are in the silver layer, right? So that we were just seeing the medallion architecture where we have bronze, silver, and gold, right? So in silver, what we have discussed, that we will be doing the transformations on the data and then store the cleansed and enriched data, right? With a better data quality, and then whatever transformations we need and all that. So when you do aggregations, you normally put into a different layer, which is called the gold layer. Okay. So let's go back and see if we have, so all of this is not persisted. So we will have to again go back and run this stuff. All of this, let's see if we have the database tables. Okay, we will create this and we will also add gold here, right? And let's see. Already exists. Let's see what databases we already have here. Okay, we have bronze and silver already. I think I have already executed some of it. I have created this table also separately. Let's go back and just create. Okay, which database we want to create now? Yes, you have to unmute and help me.
Gold.
Gold. Okay. So let's just this is SQL comment. Oh. Okay, just create gold database. Okay, that's done. In the bronze, we are writing the bronze table. Okay. And let's look at, we have done the override. So we already have this count. Okay. So we don't need to again read from the same table that we have already done. These are all the queries. We don't need to do this. This is how we, once we have it, data or data from the SQL, it will put into a default data frame called _SQLDF, which will be available for you if you want to copy into any of the data frame for further processing. Like Murli, you are saying, right? So you are able to do using SQL. It doesn't matter. Once you get the data, you can again assign it to the data frame. You still have the schema here, right? So you'll have movie ID, title, genres, whatever you want to do. So that is still available. And you can also, like, as I said, create temporary view and then do the SQL on that from the data frame. It's like interchangeable. You can, from the data frame, you register a temporary view and do the SQL on top of that. And then whatever result you get, you can again convert back into a data frame by assigning it to a new variable within the Pyspark cell, right? Or you can directly use data frame transformations to give you a new data frame. So here we are doing data frame transformations dot filter, where movie ID is greater than 100, movie ID is DF. We are selecting ID and title. That's it. So these are the two kind of data frames that we were doing using the transformations, right? Just to look at the data, movie ID, title, genres, and all that. Where movie ID greater than 100, we can do again same SQL. You will get the same result here, right? Now, so this is, I don't know why ratings DF. Okay. Oh, we have loaded, we need to load the ratings DF as well to join the data, right? We did join. Shanmuga, Ravi, remember?
Yes, we have joined the two tables. Yeah.
Yes, right. So this is how we got the ratings DF, and then we used SQL here to do the SQL join. Movie stamp cannot be found. Okay, which means we have not executed that cell where we have registered movie stamp, right, as a temporary view. Now, if I have this movie stamp, then I can go back here and execute the join. Okay. You can do the same thing I said using the data frames syntax also. Join this on this ID, and then we selected some of the, this is called chaining, right? So we are doing taking two data frames, joining, and then selecting columns and then renaming the columns here, adding a new column here, and then doing a filter. So all of these are transformations. Okay. And you get the data here. So whatever you get is in the data frame. Now this is a transformed data, right? How do I do this? Then I can take this and then write it to Go. So we have done more in here. We added a new column called release year, and we kind of truncated it. Sorry, substring. We took a substring of the last, 4 characters from the end, right? We took -5 to come here and then took 4 characters to the right. So which we thought will give us the year. Okay. So let's execute this. Are you guys following?
Yes, Arun.
Yes, sir.
Okay. Manasa? Because
Yes, Arun.
okay. All right. So anyone who can explain this, what we are doing here? This complete cell.
So basically, we are taking a data frame transformer DF. So we are joining movies data frame on ratings DF by using movie ID dot select. So we are selecting the column names, movie ID, title, gens, rating, user ID. So we are changing the column name with the dot with column rename by changing with the title with movie name, and we are placing a new column with column release year, and we are using the movie name substring by specifying the range like -5 and -4, and we are creating a new data frame, and we are filtering by using the old data frame, which is transformer DF, and we are using the column name release year greater than or equal to 2000, and we are displaying.
Right. Okay. Awesome. So everybody got this right? So this is basically how you do your transformations. You write all your logic here, to do any transformations on the data frames. The same thing you can also do in the SQL as well, as we have seen. You just register movies data frame and ratings data frame as 2 temporary views. And then you can do all your SQL there. And whatever result you get, you can again convert back into the data frame, right? So here I am doing this movies final. Okay. Silver is already there. And then I am writing the movies final in the silver layer. So this is my enriched data. Okay. How much data I have here? Okay, I have most of the data, right? Now, if I do a SQL, what am I doing? First thing, I'm trying to get, what am I trying to get here? Murali, Subbu?
Yeah, we are getting the number of movies released in each year.
Yeah. So we want to know how many movies released in a particular year. So what we do in the SQL, I know some of you are new to SQL as well, but please practice the basic SQL. Your select statements, where clause, joins, and the group by, having, count, and all of these, and the aggregates like min, max, average, all of that. Okay. So basic ones, you should be good. Okay. But very important. It's definitely needed. You have to practice that. Group by release year. So I get in 1953, 153 movies were released. Okay. So this is aggregate. Now what I want to do is, see the same thing I'm showing how you can do with the data frame dot group by release year dot count. So you get the same release year and count here. Now you want to go back and write this data into a gold layer. Okay. So what you will do, this movies count.df. So first what you'll do, you will select, so we know the gold schema, right? So table name, we want to do movies by year. Okay. So I am writing gold dot movies by year. This is my table name. Now, how do I write this data into the table? Anybody? Subbu? Want to give the syntax for this? This is the data frame, right? I want to write movies by year. It doesn't matter if you want to write this or you want to write this, but this again, you have to convert to the data frame. So here I already have a data frame. So I want to write this data frame to the database. How do you write this?
Is it save as type table? Save.
Movies count dot
write.
Yeah.
Dot format.
Subbu, where are you? I'm not able to hear you.
Yeah, I'm here. I'm telling.
Come on.
Yeah, right. Dot format. And I forget. Delta.
Yeah.
Mode. Dot mode.
Mhm.
Overwrite. Save as table. Table name.
What is the table name here?
Movies by year.
Dot save as table. Now I want to give this thing. So don't get confused by variable name. Okay, this is same as I can also just use this one here. Okay. Now let's try this. Movies count df is not defined. Okay, we'll run this because we have not run this. That's in the notebook. It's not, it is not able to recognize in the memory. It's still not there unless you execute this. That is when it gets created. So now we have created this. We can go back and run this. Okay, this is done. Now we can go back. There's a gold movies by year. And then you can see the sample data here. Now, if you observe, there are some issues, data issues here. You see here, this is not an actual year, right? This is also not correct. This is not correct, right? So there are some issues with the data, which means your transformation is not correct. You're still not enforcing all the validations, the data quality, right? So if this is what you write to production, it will definitely fail because in production, you will actually enforce the schema, right? Not in production, anywhere in the industry, even if it is in bronze. Okay, except for bronze. Bronze, you can have any data type because you expect data quality issues in the bronze. But when you move to silver, that is when you have to enforce all your data quality, which means as Sai was talking about, the typecasting as well. If the data is in a string, year, we know it has to be integer, right? Correct?
Yeah.
So if year has to be integer, then you cannot So this will fail. If it is an integer, your data will fail because it is having all of the characters there. Right? So somewhere your parsing is not correct. So that is how you have to do troubleshooting. So here it has not failed because you have given the schema as you have not given the schema. So let's say what schema it has taken here. Silver. This is movies final. We don't want this. Release year and count, right? So if you see here, see release year is string because it has detected characters. So that's why it has defined as a string. Okay. Now, how do we know whether this is correct or not? So we have to look at the data first. So what this data is and where it has gone wrong. Okay. How do we get that? Okay, we have movies final right here. Let's say we have created as a temp view. This is still available. Now I will just check. Select star from movies final. Where? What do I want to see?
Count.
I want to check what this data is, where we are getting this error. Okay. Where release year equal to or let's say release year in. So what are we seeing here? 0, 1, 1, right? This one. What is this record? And I think we got one this. So let's check these two. Okay. So if you see here, why is this failing? Let's talk about this.
Because of brackets, it's a 4 count only. Last 4 digits you take it.
Right.
So we have to eliminate the brackets. The
So the movie name does not have
Here.
an year appended to it, right? So since we don't have the movie name, movie year appended, the last, from 5, -5 will come here, and then these will become the 4 characters, which means our assumption thinking that, the last 5, 4, 6 characters is the year failed here. So that's why we didn't get the proper data in the release year. Now, what happened here?
Some trim issue, I think. There is a space.
Right. So the characters 1, 2, 3, 4, 5 and 4, 1, 2, 3, 4. So probably there is one more character at the end. Right? So what we need to do this? We have to first at least change. Just let us note this somewhere. I will just put here. Okay. So these are the two IDs we are seeing issues. So this is anyway issue. We'll talk about it later. Okay. For now, how do we fix this? So we said when we are doing transformations right here. So movie name -54. So what we have to do before doing this, we have to do the trim, right? If there are any extra characters, so we have to trim that. So how do we do that? So what, do we have a function to do that?
Already we use a substring, right?
Yeah, substring we have used, but substring works on this column, right? So before we
Yes.
take the substring, we have to trim that. Okay.
Okay.
Now, so let's check here. See the syntax. How do I
I
trim
think we
data frame column trim? Okay. So here we have trim function. Okay. So dot trim this value. So we can just go and try that here. Trim. And let's try this.
Yeah, we need to import.
Yeah. So let's do trim here. Okay. Awesome. So we have done the trim now. Let's get the new temp view movies final. Okay. And then run this. See, now that is gone. So we don't have this issue anymore. This issue anymore. Right? Now, if you run this again, this will go away. You will not find this because that issue we have already fixed. Okay. But we also have where this is missing. Some movies where the ear is missing. So you have to also check that. So how do you check that? Once you take the substring, you have to verify if that is a integer or not. Only if it is an integer, you have to consider. If not, you skip that record or drop record, something like that. You have to keep doing all of that. So that is how you do the data validations. Okay. Or so once you have this, right? Once you get this transform df, you can also filter out. Here you can write condition release year is not integer. Typecast. Okay. So those conditions you can write and then filter the columns. Gotcha. Any other questions?
So Arun, whatever the functions in SQL, so all functions are available in Pyspark as well, right?
Yeah, that's what I have given you here, the documentation, right? So
Yeah.
whatever is available in Pyspark functions, so these are the functions that are available to use.
Okay.
SQL functions. All of these are available. Okay.
Yeah.
Yeah, you can just check the document. There's so many, exhaustive list. Almost whatever you can do with SQL, most of them are here. You can do no value. You can do null if is not null, if null, right? Type of.
Can you please show that typecast function, how it is used?
Yeah, sure. One second. So data type of the input.
Dot casting.
Yeah. That I'm checking something. I'm looking for something else. So lowercase in string. Okay. Casting, right? So you can just let me check. Same thing. Yeah, there's a cast function is used to explicitly change the data type of a column. So how you want to use this? Just new column, desired data type.
Okay, this is okay. So this is to change the data type, but in the example that we are working on now,
Mhm.
isn't it our goal to exclude the movies that doesn't have the year, release
Yeah,
year?
so you have to figure out a logic how you want to do that. Okay,
But
it
can,
does
can we
not
still
give
use
you
the
out
cast
of the
function?
box. Huh?
Can we still use cast function for that?
Let's see, right? We can try that. So we want to, it should actually fail when you try. That's what it is. That's how it should work, right? So we are trying to do a typecast where the data is not uh, does not satisfy the data type. Okay.
Okay.
So dot with say column. So we have again release year, right? So I will say a release year int. So I'm converting to integer that release year. So how am I converting that? Movies underscore df of. So I have release year already here.
Yeah.
Okay. So I take this release year and then use
Dot cast
cast
integer.
integer. Let's try this. With name release year cannot be resolved. Oh, no. I think we have to in movies DF we don't have this. Okay. So what we can do
In substring itself, we have to use dot caster.
yeah, we can use that, but I don't want to complicate that here. I'm just creating a new data frame and just say with year int column. And this is already the transform DF that we have the release year here, correct? So let's try this. Okay. Transformed year int. So it worked. Okay. It's casting to integer, but what happened to those rows?
Yeah, does it give any message that it ignored or excluded a couple of rows?
It should actually. Transformed DF. This is release year int. Okay.
So we have those movie IDs, right, Arun? So we can check those movie IDs here.
Yeah. So
if it comes there or not.
yeah. So it's the transformed year int. Now let's convert.
Yeah, you commented somewhere those three movie IDs.
Always final, right? And then run this. See here, it has actually taken null value where it cannot convert the integer. So if you want to
in the data frame, but it really didn't ignore that.
Yeah, it didn't ignore wherever it could not. It's a soft, and then it handled the issues with null. So then you can do, filter those null columns, right? Where year is null.
Yeah.
Filter column where see, I'm taking this data frame here. Okay. Now dot filter column, which column release year int.
Instead of this, can we search for a substring four characters has number?
Yeah, you can do any number of things. Okay, you can do regex. can write whatever logic you want to. What is the syntax for not null? Okay. Column. Where do you have the transformations?
Since it's an integer, should we look for a 0 instead of null?
It's not, I don't think it's 0. It's null. But anyways, you get the idea, right? So how you handle that? So you cast it and then you filter if it is null, basically. Or you can enforce, the schema as well.
Okay.
Once you do that here, I don't know, I have kind of, so okay, this is the integer and I'll just use this with year int. Okay. Then if you look at, see the release year is string, but release year int is integer data type. So you basically converted string to integer. You can drop this column and then filter these values. So those are the transformations that you write as part of your data enrichment, data quality.
Okay.
Okay. All right. So those are the transformations. Now, again, as I said, you can do multiple aggregations, right? So now this has changed from transform df to transform df year int, right?
Harun?
Yeah.
So by default, the data type will be in string always?
Yeah, it will infer the data, right?
Okay.
So whatever data you have, it will always try to take the string, but it's not always string. See here, movie ID, it is still integer.
Okay.
Rating is double. So it's based on the data you have.
Okay. Yeah.
Yeah. So this we have done. This we will write movies final schema mismatch detected. Okay, so this is one of the concept that I was about to talk to you regarding the Databricks Delta. So earlier we have already written the table movies final. Okay. But what is the schema of that? If you go here, catalog, silver, movies final. See here, movie ID, name, genre, rating, user ID, release year. 6 columns with this string. Now, the data frame that you are trying to overwrite this table with, the schema is changed now. There is a new column that is coming in, right? You added release year integer column. Yes, are you following?
Yeah, got it.
So the schema does not match. So it fails. So you cannot write any data to it. You cannot append or you cannot overwrite data. So how do you handle that? So one of the feature Databricks Delta handles is called schema evolution. Okay. So schema evolution is you can always opt to merge the schema, the incoming new columns. If there are new columns, you can always give it an option to merge the schema, new schema. Okay. So where is that? We'll go here. Okay. So here, I do dot option. Is it merge schema? Well, again, so it's all syntax things. True. Let's try this, whether it is merge schema or something else. No, it's not. Saying true. Let's say true. Awesome. It worked. Okay. Now, okay, these are all the jobs. You can go back here in the catalog and look at the schema now. In the silver movies final. See, now you have new column. Release year int, which is data type integer. So it is a schema evolution. If you merge the schema, it will automatically add new columns if the new data frame has, or if it is not there, it will overwrite that. Remove the columns if it is not there. So that is the merge schema option that you get. But the values, if you are in the append mode, all the previous values it already has will just be null. You cannot recalculate those, but going forward, you can add that new values to the new column. But old data for that value for that column for the old data will be null. Okay. So that is the schema evolution. Now let's go back. I'll just do one more thing here. Okay, so we set out to do these aggregations and write to the gold layer, right? That's what we wanted to do. And we were trying to do all of this. Where is that? Where did we go? Okay, so this is the one, right? So we have written this. Now it is null. Release year. Now what we have to use? We have to use the release year int instead of release year, correct? Because release year is a string, it has still invalid values. Okay, now you see it's everything on the right side. Release year is integer and we have null values. Now we can see how many values total are invalid. So there are 19 movies which does not have the year in that title. So that is null. Now we can go and just write this to the gold layer. So is this the transform DF that we are using? Which data frame? This one, right? This is what we used to write the data to the table. Okay. So I will take that data frame. What else do I need to change here?
That's all.
Column name.
That's it. Murali, Subbu.
The column name is integer, right? Group by.
Yes. Release year underscore int. This is what we are using. Okay. So this is the movies count data frame. Now I can go movies by year, overwrite this to gold. Again, same issue, mismatch. Okay. So earlier we had string, now it is a data frame. So let's say we can do dot option merge schema true. Right. So this is the data that we have created in the gold layer. You want to go and check here in the gold movies by year. This is the aggregate that you get. Oh, okay. So earlier we had release year. So when you merged it, it still retained that, put all null, and the new column it has added release year int. If you don't want that, you have to explicitly go drop that column or drop the table and then recreate it. That will be new data because you are overwriting. You will anyway get all the new data. So this also clears up, right? What happens if we remove one of the existing column? So it will just make it null for all of that data because you are overwriting. That will still be there. It will only add new columns. All right. So you guys are clear? I'll just.
So there is an option like Arun, if I want to keep both.
Keep both what?
I don't want to be null value for those in the old column.
It's up to you, right? What you are providing in your schema when you are writing. Correct? So when go here, batch processing. I think I should actually have another thing here to the catalog values. Close this. Okay. So we're talking about the gold, right?
Yep.
Yeah. So this one, we said merge schema and movies count data frame. Your movies count data frame only has release year int and count. You don't have the release year. But if you want to do it, group by both release year as well. Okay.
Yeah, I got it.
Then you will have 3 columns. Then you write this data frame. Then the data will go into the release year also.
Yes. Yeah.
Because you're overwriting. Good?
Yes, sir. Yeah.
Okay. So I'll just remove it so that you don't get confused here. All right. I'll just give a 2 minutes break, washroom break. You guys go just walk about this. So this is the gold layer. Now, the same thing, what you do is you do different aggregations. Whatever you want to see the data, you want to filter the various other questions we talked about, right? Where is those questions? So here, what is the average rating for each movie? You just do the same, all the data frames, transformations, aggregations basically, and write it to the gold. What is the minimum and maximum rating for a movie? Right? What is the minimum and maximum rating for each movie, say for example? What is the minimum and maximum rating by each user for each movie? Make sense?
Yes, sir.
If you, for each movie, you want to see what is the minimum rating and what is the maximum rating given. Now here, for each movie, what is the minimum and max? So not for each movie, by each user. One user, what is the minimum and maximum rating he has given? Again, you don't get for each movie. For movie, you get only one rating, right? So I want to see what is the minimum and maximum rating each user has given. And probably it will become complicated. I want to see which movie that was minimum and maximum that he has given. But you can take for each user, what is the minimum rating is given for the movies, what is the maximum rating is given for the movies. So like this, you can answer a lot of questions. You can also do what is the average rating given by each user. So this will tell you the the demographic, or you will get the trend of based on users. So what is the average rating the user is giving for any movie? So is he giving all 4s and 5s? His average rating is 4.5 or 5, or he's very skeptical, critical. He only gives 1 star, 2 star for all the movies. So the average is only 1.5 or 2, something like that, right? So when you're doing, you take out the movies where he has not given any rating. Consider only the rows or the movies where he has given some kind of rating. So all of this is what the scenario, your filters, your transformations that you do for aggregates. Does this make sense? So you can remove this for now. Does this make sense, guys?
Yes, sir. Yeah.
Okay. Why is that all coming? There is some syntax for this also. I don't know what. Maybe this. Yeah. Okay. So you can try to answer these questions using the aggregations and writing to gold table this week. Practice this. Just give me 2 minutes. We'll come back and I'll introduce you to some of the concepts of Delta, Databricks Delta. And then tomorrow, we will continue more concepts of completely the Delta, what happens, how it, what are all the features of Delta, how is, all of data is stored, time travel, we were talking about, so that we will do tomorrow. We'll do some transactions. We will go back in time and see how the time travel works. What are the features of Z order and vacuum? What do they do? And how the delta log, how the Databricks Delta supports ACID transactions, and how we read the delta log and how it uses delta log for performance. So all of that we will discuss tomorrow. Yeah, I think let's continue. We only have 5-10 minutes. Then we'll continue tomorrow. Okay. Any questions before I wrap this up and move on to the Databricks Delta features?
So Arun, actually, I pinged one SQL query. So that's what actually I tried. So the movies which are less than the total average movies, I'm trying to find it, but yeah, I don't know how to do it in the data frame. Yeah, I'm pinging in the chat.
Yeah, okay. Select movie rating.
It's a kind of the self join actually. So
Average rating. So what are you trying to do here?
So the movie ratings which are less than the total average rating. For example, if you take the total average is 3.5, right? I want to get the movies which have less than the 3.5 ratings of average.
Okay. All right. Okay. Let's see what you done. Where is the okay? So release so you want to do the rating, right? Okay.
Yeah, if you take, for example, if you take the total average, it comes on 3.5 or 3.6.
No. I understand your thing. You're trying to see what are the movies that are less than the overall average.
Yes. Yeah.
So average rating for that movie is less than the average rating of all the movies.
Yes.
Right? Yeah. So when you go here, where is your rating? Yeah, rating is here, right? And movie name is here.
Yeah.
Which is your movie's final. So this is what you're trying to do, correct?
Yes. Yeah.
So this is the sequel you're trying to write.
Yes. Yeah. The sequel is working.
Sequel is working?
Yeah, sequel is working. So I want to try that one in the data frame.
Oh, you want to try that in the data frame?
Yes.
Yeah, it's just about syntax, right? You have to just try with the aggregate syntax, how you do the data frame aggregations. And then you can create both data frames and then do the aggregations. Okay, so
yeah, I will try again.
First you select, you kind of add a column with column to the data frame with average rating as this aggregation. And then again you do another aggregation on the same data frame using this column rating less than this column. Okay, so it's all about syntax. It's not like you can how you do it.
Yeah, the syntax how you write.
Try and thing, but as long as it works, SQL is, as I said, right? SQL is also absolutely fine. You just do with the SQL, or you can actually write the entire SQL itself in the data frame. Dot select expression. You can write the entire spark.sql. You can write your entire SQL and it will give you the data frame. Or you can also do data frame dot select expression. There also you can write your data frame.
Okay.
Your SQL in the data frame. So
yeah, you can convert your tables here. It works. Yeah, the SQL works.
Okay, yeah, that's fine. I mean, if that works, we will leave it at it for now because we don't want to get too deep into the syntax things.
Yeah.
First, let's understand the concepts.
Concepts.
Right. And then it's not a big deal. You just have to try the syntax and then work it out. Okay. So and long story short, it is possible. It's not like something which can be done in SQL cannot be done on data frame. No, everything you can do in data frame, you can do in SQL. Everything you can do in SQL, you can do in data frame. Whichever is simple, you can use that. Whichever is comfortable. You don't have to. That's why I said there's no hard and fast rule that you only have to do in the data frame. SQL and Python are by default accepted. You can do either in SQL or in data frame. But you can do, it is possible in both. Okay. Now, okay, I wanted to show you. So we were talking about the this data, right? Whatever we are writing the data frame. So we are saving as table, correct? Bronze, silver, whatever. So we have saved the table called movies, right? Bronze.movies. Now, when I do a describe, Srini was also talking about this earlier. When I do a describe extended bronze.movies, it gives me the information of the table, okay? And it also gives me a location where it is storing the data for that table. So whatever you're writing the data frame, the table, somewhere it has to store all the data, right? So it takes what is the column name, title, genres, and the detailed information. What is the database? What is the table name when it was created? Table type, whether it is managed or external. We will talk about this as well. Very important concept, managed tables and external tables. For now, managed, you can say this is completely managed by the Databricks, whatever you're writing, both the data and metadata table. Location, this is where all your data is getting written on the storage.
Arun, is it similar to Hive tables?
Yeah, it is similar. So this is actually using Hive Metastore only here.
Okay.
Okay. Unity catalog, when we go, it will be similar to Hive Metastore, but all the Metastore metadata is handled by the Databricks on the Unity catalog.
Okay.
But metadata does not have anything to do with managed or external. External, as I talk about, in the managed, data and metadata both are owned by
Hive
the owner.
database. Yes.
In the external, when you create, you only own the metadata, not the table. You are just pointing it to a location where the data is already there, right? So when you drop that, you only the table gets dropped. The data will still be there in external. But managed, when you drop the table, both data and table both get dropped.
Metadata. Yeah.
That is the concept. We will talk about it in detail later. Now, this is the location where your bronze database movies are stored. Data is stored. So I can take this location and go to DBFS and say, show me this path. What are the files here? Okay, so this is the path where the movie's data frame is stored. Now, if you see here, the first folder here is delta log. This is the folder. This is where all the metadata about files is stored. The Databricks Delta, it stores all the metadata about your files here in the delta log. And if you can see, these are the actual data files. Part 00, Snappy, Parquet files. This is where your actual data is. This is the name of the file. What is the size of the file and what is the timestamp. So these are actual data files. Now this is the metadata. Now I want to see what is there in the metadata. What does it write in the delta log? So this is the most important concept of Databricks Delta. The entire what happens behind the scenes, how does Delta work, is all based on this Delta log transaction tables. So when you go to Delta log, okay, see here, inside the Delta log, you have all of these files. You have CRC files, you have JSON files. So each JSON file is a version. It's same as your, table versions, you can say. It maintains, for every version, it maintains the JSON files here. So there are like 8 versions that are created till now. You have the name, JSON file, and size and modification date time. Now, what is there inside this JSON file? I want to see. What does it write in the JSON file? So I just took one file, JSON file here, and then I'm just reading head, the details of the file. Okay, so this is the JSON file. You have all of this: notebook, cluster ID, output, format, all of this stuff here. So if you want to see clearly, so it's just a JSON file, right? We can read CSV files, we can read JSON files. So what I'm doing is I'm just reading that JSON file as a JSON, spark.read.json. We will talk about how to read and parse JSON files in the upcoming classes. But for now, let's just say we are reading this JSON file, and then I'm displaying that. This is version 0. Now here, if you see, the structure of the file is this. It has data change, modification, path size, tag, insertion time, commit info, cluster ID, notebook, metrics, operation parameters, metadata, everything. Now, if I just say display dot select this part, see here in the file what it writes. It writes the size, modification time, data change is true. It also writes the stats. This is the most important part. What are the number of records in this version? Minimum values for each column. Movie ID, minimum value is 1. Title, these are all strings. All right. Maximum values. Movie ID maximum is this. This is the information that it uses when you write any query. Okay. It scans these delta logs and sees which file has information. What is the movie ID max min in this file? What files it has to scan for that data? All of that is done by scanning this file. It has insertion time, tags, everything, null count, all the statistics, and it has a lot more information. Okay, we will dig deeper into this, but for now, just understand this is what it has. The transaction log, delta log you call. Okay. So tomorrow we'll continue. We will deep dive into the Databricks Delta, the features, and behind the scenes how the Delta works. Fair enough? Are you guys good? Any questions?
No, Harun, we're good.
Okay. All right. Tomorrow we'll do more transactions on these tables. We see how the log transactions, delta log transactions are created, log files are created, how the versions are created, how we can do time travel. All of that we will cover tomorrow. Very interesting features, exciting topics tomorrow. Okay. But please practice and try to come up answers for these. All right. We're all good. Questions, comments before we wrap up?
Yeah, I'm good, Arun.
Okay, Subbu.
So to read the log files, so based on the errors, we have to go through what you give the different syntaxes to read the logs, right?
We don't need to do errors. These logs are basically one is your data files. Whenever you write to the table where the files are getting written, where the data is getting written, and the metadata about each transaction or each version of your table when it is getting created. So those are the delta transaction logs. That's how it provides the ACID transactions. When you delete some of the data, it stores the information. Okay, in this version, this data is deleted. These files are not relevant right now, right? So whenever you do some query, it will make sure that you don't get that deleted data back unless it is permanently deleted later by vacuum or whatever feature. Okay, so we'll talk more about it tomorrow.
Okay.
Ravi, Shanmuga, are we guys
Yes, Arun, I am good. Yeah.
I'm good, Harun.
us? Ranjit?
I'm good, Harun. Yep. Thank you, Harun.
Yeah, good. I'm good on my side, Harun.
Okay, awesome. Vedavyas, Venkat?
Yeah, I'm good, Arun.
Okay, Venkat, are you getting the concepts? Are you practicing?
Yeah, basically I started practicing transformation, but I got a couple of things, couple of doubts. So just I want to, once these 2 days also done, then I'll come back to you some couple of things.
Sure. Okay. Yeah, Vedavyas, we are good.
Yes, sir.
Okay. All right. Great. I will publish this notebook and also the video recording by afternoon or evening once all that is processed. But keep practicing. We will meet tomorrow. Okay. All right, guys. Thank you so much. Yeah. Thank you.
Sure,
Appreciate it.
Harun.
Have
Thank
a
you.
good day. Meet you tomorrow. Bye.
Bye-bye.
Yeah. Bye.